This is 3.8 and day 1 homework. Okay, we want to solve this. So first of all, let's get it in the right form. So put it in standard form, equal to 0. Okay, we can factor this one. Okay, it's x squared times x squared. And to get negative 6, I have negative 5 times negative 1. Okay, and then to solve it, I set both of these factors equal to 0. Add the 5 over, and take the square root. And add your 1 over, and take the square root. Square root of 1 is 1. Okay, next one is number 8. Okay, so this one also, we're going to get it equal to 0. So subtract that x over. Factoring this, greatest common factor, we can take out an x. And then set them both equal to 0. Okay, so we get x equals 0 is one solution. And 1 and negative 1 is the other solution. Number 12, distribute this through. Okay, and then we can get it equal to 0. So I'm going to leave this here. I'm going to subtract that over. Subtract that over. Equal to 0. Okay. I think we can factor with this. So you take out an x squared, left with 3x minus 2. And here we can take a 9, actually negative 9 out, because we got to change the signs too. And then be 3x minus 2. So our factors, one of the factors is the 3x minus 2. And what's being distributed to that, the x squared is, and the minus 9 is. So to solve, set them both equal to 0. So add the 9 over, take the square root, so plus or minus 3, and add the 2 over and divide by 3. Okay, 16, it's already equal to 0. So let's factor again. 4 terms grouping. Here we take out an x squared, 5x minus 1. Here we take out a 2, 5x minus 1. So my factors would be 5x minus 1 here, and the x squared is being distributed through it, and the 2 is being distributed through. Okay, set them both equal to 0 to solve. So here I get x squared is equal to plus or minus the square root of negative 2. Whoops, not, we took a square root, so it'd just be x. So x is equal to plus or minus I square root of 2. And add your 1 over and divide. And you get your answers. Remember, there's 3 answers. 1, 2, 3. Okay, number 20. Number 20, we can factor this. I'm going to use 4x squared times x squared. And negative 25 and negative 1 will give me negative 4, and negative 25 give me negative 29 together. To solve it, set them both equal to 0. So 4x squared is equal to 25. I'm going to use square root method for both of these. Actually, you could factor this one farther. Well, let's do that. Let's factor it farther. Either way would work fine. So it'd be 2x minus 5 and 2x plus 5. Okay, then we can set them equal to 0. Oh, x squared minus 1. Oh, hold on. You can factor that farther too. You could just use a square root method and do it, but x plus 1 and x minus 1. But if we want to factor them all the way down, you can do it this way too. Okay, so you add the 5 over and divide by 2, and you subtract the 5 over and divide by 2, and subtract your 1 and add your 1. Okay, and then it says to look at the graph of this and just to verify. And if you look on Desmos, if you graph it on Desmos, the graph looks like this. We know our solutions are these points here. So at -1 and 1, and 2.5, which is 5 halves, and -5 halves. Number 24, we have 4 terms. Factor by grouping. So here you can take an x squared out, x plus 6 left. I'm going to take the signs to the same. I'm going to take a -100 out. Be x plus 6. So x plus 6 is one of my factors, and the other is x squared minus 100. Okay, we can take this down farther. It's a difference of squares. X minus 10, x plus 10. And set them all equal to 0 to find the solutions. So I get x equals 10, x equals -10, and x equals -6. And you can go on Desmos. It's going to go through at -10, at -6, and at 10. So it looks something like that. (28), we have 4 terms, factor by grouping. Take out an x squared, x plus 3. And this here, we want to get the signs the same, so we make it negative, and we can 57 divides by 19. 3 19s make 57. Okay, and our factors would be x squared minus 19 and x plus 3. Okay, so that's not a difference, it's a difference and that's a square, but 19 is not a square, so we're just going to set it equal to 0 and use the square root method. So x squared is equal to 19, so x is equal to plus or minus the square root of 19. Okay, and if you go the square root of 19, since we want to check it on Desmos there, oh, I keep hitting the wrong buttons on my calculator. Square root of 19 is approximately 4.36. Okay, so if we check it on Desmos, okay, it's going to intersect at 3, at 4.3 something, and -4.3 something. Okay, so it's going to look something like this. I'm not sure how high. Whoops, not there. Right there. I'm not sure how high and low it goes, but that is the gist of what the graph looks like. Not here. Okay. Okay, with 32, I'm going to take out a greatest common factor of 2x. Left with x squared plus x plus 6. Okay, that one will not factor. Make sure I write it down right. Yep, not factor. I can set this one equal to 0 though. Well, I'll set them both equal to 0, but so this one, if I divide by 2, 0 divided by 2 is still 0. Okay, this one I'm going to have to use a quadratic formula, so we're completing the square either way. Negative b plus or minus square root of b squared minus 4 times a times c, which gives me -1 plus or minus the square root of, this is 24. 1 minus 24 would be -23. And the last step is to pull out that I, and 23 does not simplify, so there's your other two answers. Okay. Verifying this on Desmos, all that we know is that it goes through at 0. Okay, and there's two imaginary which don't show up on a graph. 36, 3 terms. We set these up and try and find them. I'm going to use 8x to the third times x to the third. And I'm going to use plus 1 here and minus 1 there because that'll give me 8. Minus 1 gives you 7x to the thirds. Okay, we're going to set them equal to 0. Oh, no, we're not yet because they're not. These are cubics. We can factor them. Okay, so this is 2x times 2x times 2x and 1 times 1 times 1. If you remember, that's 2x minus 1 times 4x squared, and 2x times 1 would be 2x, and plus 1. Okay, this one over here would be x plus 1, and then x squared minus 1x plus 1. Okay, so if you remember the cubic patterns, so this one here, remember how we did like 2x times 2x times 2x is 8 that, and 1 times 1 times 1. So for this one, so it's 2x minus 1 there, and then we do 4x squared, 2x plus 1. Okay, so now we got to set them all equal to 0. So this one here, you're going to add your 1 and divide by 2. We get one solution. Here you're just going to subtract your 1. We got two solutions. Now with these other two, those will never be able to be factored more, so we're going to have to use the quadratic formula. We're completing the square. I'm going to use quadratic formula, negative b squared minus 4 times a times c. Okay, this would be negative 2 plus or minus be 4 minus 16 be negative 12 over 8. Okay, this would be negative 2 plus or minus. Okay, this would be 4 times 3. Square root of 4 is 2, so 2 square root of 3 over 8. And lastly, I can divide 2 out of all those, so negative 1 plus or minus I root 3 over 4. Okay, last one over here, I got to solve this one too, because I need 6 answers, right? So 1, 2, 3, 4, and 2 more here yet. So that's going to be negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. B1 and B4, 1 minus 4 would be negative 3. And we just take that I out. Alright, that's 36. Number 40, they give us this equation and they give us the factored form of it. So we have to draw a graph, sketch a graph, and then figure out what these are here. Okay, so we know that x is going to equal negative 5, and that's a double. Okay, so that is a double there. X is going to equal, subtract the 3 and divide by 4, negative 3/4. Okay, it's a single, and x is equal to positive 4. Okay, so there's my zeros. Now we know if it's x, and the y-intercept is way down there at negative 300. Okay, if it's x to the 4th and it's positive, we know the end behavior is going to be up, up. So this is going to be our double 0 here, there, right? And it's going to have to do something to come down through here and through negative 300 and then come back up through there. So therefore we have our up, up. Okay, so where is the p of x equal to 0? Okay, we know it's equal to 0 at negative 5 and at negative 3/4 and at 4. Okay, where is it less than 0? Okay, where's my outputs? These are all outputs that are positive y's, right? These are all positives. Down here I have the negatives. Okay, so from negative 3/4 all the way through this area right here, right? These all have y's that are negative. So from negative 3/4 up to 4. Okay, and then where are they greater than 0? Okay, so here is greater than 0. Now if it's or equal to, I could keep going, but since it's not at the negative 5, I can't include that. So from negative infinity to negative 5, And then from -5, okay, it keeps going and is positive all the way through here, all the way to 3/4, negative 3/4. And then it goes negative, and then up here it's positive again. So from 4 to infinity. Come to class ready with any questions.